Okay, thank you so much. So welcome to our class where we are considering an introduction to calculus. So when it comes to calculus, we normally consider the first two methods of calculating calculus. So the first method of calculating calculus is called differential or differentiation. So in differentiation, we are trying to normally differentiate an equation. But when it comes to integral, or also known as and differentiation, also known as and differential, this is when we're trying to get back to the original equation of differentiation. So we'll focus on the common used method of calculating or differentiating equation. So for example, given equation, say y is equal to 2x squared plus 3x, then we are differentiating using the power rule. So we are differentiating this equation using the power rule. So the power rule is one of the common used methods to differentiate equations. So in the power rule, we say d over dx, then x to the power n is equal to n number, then x n minus 1. So this is the formula we normally consider when we are using the power rule. So now we are differentiating the equation y is equal to 2x squared plus 3x. So we'll say dy over dx is equal to 2x squared plus 3x. So now we differentiate this equation. So we'll say 2 multiplied by 2. So get the 2 power here multiplied by the 2. So it will be 2 multiplied by 2, then x2 minus 1 power, then plus 3. So we are saying that every number raised to the power 1 is the number itself. So here we take it there is power 1 because every number which is raised to the power 1 is the number itself. So it will be 3 multiplied by 1, x1 minus 0. So then we say equals 2 multiplied by 2, then we have 4x, then 2 minus 1 power, it gives us 1, then plus 3 multiplied by 1, that gives us a 3, then we are saying 1 minus 1. So since every number raised to the power 1 is 1 itself, so we say 1 minus 1, then that gives us a 0. So it will be 3x multiplied by 1, then x to the power 0. So then this gives us x to the power 1 is x plus 3 multiplied by 1, that gives us 3, then x to the power 0. So any number raised to the power 0, it is 1. So it will be 3 multiplied by 1. So this gives us so it will be 3. So x to the power 0, that gives us a 1. So this is now 4x plus 3. So we are saying 3 multiplied by 1, that is a 3. So we are saying dy over differentiating equation y with respect to x gives us this one when we are using the power rule. So we now go into the second rule, which is the first principle. So we said we differentiate the same equation above using the first principle, of differentiation. So now we are considering the first principle, and we are given this equation. We are considering y is equal to 2x squared plus 3x. So according to the first principle, we are saying dy over dx is equal to limit h is equal to 0. Then we are saying f function of x plus h close bracket minus function of fx over h. So this is the formula when we are using the first principle. So when we are calculating the first principle, the first thing we have to is to find the function of x plus h and as well the function of fx. So say the function of fx plus h. So the function of fx plus h is, we'll say, is 2x plus h. Then plus so this is squared, then we'll say 3x plus h. So this function is, we are getting our equation which we have been given, y is equal to 2x plus squared plus 3x. So we say 2x, then this is our 2x plus h which we have been given, then to the power x. So this is the power x we are seeing. Then we go to the second part of this equation, which is z plus 3x. So we have our 3, so this becomes our 3, then everything to the x plus h function. Then we have to now find the function of x, which is here in the formula, which is fx. So we are saying f function of x. So the function of x is the equation which we have been given here. So this equation is a function equation. So we say 2x plus 2x squared plus 3x. So this becomes our function of x. So once we have the function of x and we have the function of x plus h, we can now replace these variables into our limit formula, which is the first principle formula. So we will now replace this into our formula. So we'll say dy over dx limit h is equal to 0. So then our formula is fx x plus h plus minus f function of x over h. So now we are replacing in the formula. So we will have 2x plus h plus 3x we have plus x plus h. So we are replacing, then so the minus the function of x. So we have now minus 2x squared plus 3x over h. So from this point now we can factorize this fraction. So we can factorize by now. So this will be 2. So this is, there's a squared here, so this will be 2x plus h. Then we expand this because of the squared, so we are going to expand what is in the bracket, then plus 3x plus h. Then we subtract, so the minus is multiplying everything which is in the bracket, so negative multiplied by 2x, so it will be 2x squared minus 3x over h. So from here we can again factorize, so you say equals, so say 2 multiplied by x, so it will be 2x plus 2 multiplied by h to be 2h. Then we have the bracket x plus h. Then 3 multiplied by x, it will be plus 3x. Then 3x multiplied by h, it will be 3h. Then minus 2x squared minus 3x over h. Then we proceed. So since we have now 2x plus 2h, then 2x plus h, so we can now factorize this. So we'll say 2x h plus h, then plus 2h, you can say x plus h, then plus 3x plus 3h minus 2x squared minus 3x, then over everything by h. So then we can factorize again. So we say 2x plus multiplied by x, it will be 2x squared. Then 2x multiplied by h, it will be plus 2x h, plus 2h multiplied by x is 2hx. 2h multiplied by h to be plus 2h squared plus 3x plus 3h minus 2x squared minus 3x over everything over the h. So since here we have common variables, so we shall cancel the like terms. So the 2x will go with the 2x squared. Then the 3x squared will also go with this 3x squared here. So we'll now remain with the 2xh plus, so 2xh plus 2xh plus 2h squared plus 3h over h. So since we have the like terms here, we can say 2xh plus 2x, that will give us a 4. So this will become 4xh plus 2h squared plus 3h over h. So we can now simplify further. So this equation is the same as, can be written as 4xh over h plus 2h squared over h plus 3h over h. So this equation is the same as this one. So here we can now, the h can now cancel. So this h will go with this one, then that h will, there will be, now will remain with 1h. Then this h will cancel with this h. So then we will have 4x plus 2 plus 2h plus 3. Then we are told that then this is equal to, so then this is equal to, we are saying dy over, we are saying that dy over dx is equal to limit okay, let me write properly. So we are simply saying dy over dx, then limit h is equal to 0, then 4x plus 2h plus 3. So since our limit is h is equal to 0, so where h will put 0. So say 4x plus 2, then where the h will replace with a 0. So this will be 2 open bracket 0 close bracket 3. So our dy dx with limit h is equal to 0 now becomes 4x. So 2 multiplied by 0 is 0, so it will be 2x plus 3. So therefore dy over dx with limit h is equal to 0 is equal to, so this is our final answer when we are differentiating using the first principle. So thank you so much for following, and please don't forget to subscribe so that and hit our like button so that you can be able to get a notification once we post our next video. See you in the next video. Bye for now.